Somewhere in a stadium, a bar, a living room, Lionel Messi curls a free kick. The ball bends. The goalkeeper doesn't move in time. It goes in. And somewhere else, a person who has never kicked a professional football in their life, who will never stand on that pitch, who Messi has never met and never will, felt something detonate inside their chest. Their heart rate spiked. Their hands went up. Something that felt like pride, like joy, like personal triumph flooded through them so completely that for a few seconds they forgot they were sitting down. That feeling has a biological explanation, and it is stranger than you think. Because what happened in that person's brain when Messi scored was not simply an emotional reaction to something they witnessed. Something far more fundamental occurred. A set of neurons fired in their motor cortex, the part of the brain that controls physical movement, in almost the exact same pattern as if they had taken that free kick themselves. Their brain did not fully distinguish between watching Messi score and scoring themselves. This is not a metaphor. This is neuroscience. And understanding it will permanently change the way you think about football, about empathy, and about what is actually happening inside you every time you watch a game. In the early 1990s, a neuroscientist named Giacomo Rizzolatti was running what should have been an unremarkable experiment at the University of Parma in Italy. His team had implanted hair-thin electrodes into the brains of macaque monkeys to study how neurons fired when the monkeys reached for and grasped pieces of food. Straightforward motor neuroscience. Nothing unusual. Then one afternoon, one of Rizzolati's researchers walked into the lab eating an ice cream cone. The monkey watched him. The electrodes fired. The same neurons that activated when the monkey itself reached for food were now firing, while the monkey simply sat and watched someone else do it. The monkey hadn't moved. It hadn't reached for anything, but its brain was behaving as if it had. Rizzolati's team spent months checking the data, then checking it again. What they had found was so unexpected that it took years before the scientific community fully absorbed what it meant. They published their findings in 1992. They called these cells mirror neurons. Neurons that fire both when you perform an action and when you observe someone else performing the same action. Your brain, in the most literal neurological sense, mirrors what it sees. Rizzolatti later described it this way: when I see a person doing something, the same action that this person performed enters inside my motor system, and I have a copy of it. Not a representation of it. Not an interpretation of it. A copy. The implications of this discovery did not stay in a laboratory in Parma. They spread quickly into psychology, philosophy, linguistics, and, though it took longer for the science to catch up with what fans had always felt instinctively, into sports. Because mirror neurons do not only fire for actions, they fire for emotions too. Rizzolati's colleague Vittorio Gallese, also at Parma, ran a study where participants were placed in a brain scanner and exposed to the smell of rotten eggs, producing a strong disgust response. Then they were shown photographs of other people making disgusted facial expressions. Same brain regions. Same activation pattern. The brain did not just recognize the emotion on the other person's face. It felt it. This is why when you watch a player go down clutching their leg, something happens in your own leg that you cannot fully explain. This is why when a goalkeeper dives full stretch and misses, you feel the failure in your own body. This is why millions of people who have never played professional football, who are sitting completely still in their living rooms, feel physically exhausted after a World Cup match. Their motor cortex has spent 90 minutes running a simulation of every sprint, every tackle, every shot they watched. You were not watching the game. Your brain was playing it. But here is where it gets more interesting. Because not everyone's mirror neurons fire with the same intensity. Ornella Valenti, a neuroscientist at the Medical University of Vienna, studied this specifically in the context of football. Her research found that the more experience a person has with football, the more they have played it, the more deeply they understand it, the more intensely their mirror neurons fire when they watch it. A former footballer watching a World Cup match has a significantly richer neurological experience than a casual viewer watching the same match. They are not just watching more closely. Their brain is running a more detailed simulation. Every movement they recognize from their own playing experience activates a deeper neural echo. This is why former players make better commentators. Not just because they know the game tactically, because they are literally feeling it more than the rest of us. And here is the part that connects back to that person in the living room when Messi scored. Their mirror neurons fired more intensely because they have seen Messi score before. Because that specific curl of the ball, that specific shape of the free kick, their brain has a motor memory of watching it. And each time it fires, the simulation becomes richer, more physical, more real. This is also why it physically hurts when your team loses. When your mirror neurons have spent 90 minutes simulating the experience of playing with these players, running their runs, feeling their touches, the loss registers not just as disappointment, but as something closer to a personal physical defeat. The brain does not sharply distinguish between things that happened to you and things that happened to someone your neurons were busy simulating. Cortisol, the stress hormone released in soldiers in combat, floods your system after a loss. Not metaphorically. Actually, there is one more layer to this that almost nobody talks about. The mirror neuron system is also, researchers believe, the biological foundation of empathy itself. Not empathy as a moral virtue or a social skill. Empathy as a hardware feature. The reason any human being can understand what another person is feeling without being told is that their brain is running a continuous low-level simulation of the people around them. When you look at someone who is crying, your brain does not reason through the situation and conclude they are sad. It mirrors the expression and generates the feeling. You feel a version of their sadness before you have consciously processed it. This happens automatically, involuntarily. It is not something you choose. Vittorio Galise described this mechanism as wired into us. The neural reason humans see other people as similar to themselves rather than as foreign objects to be analyzed. And the World Cup is the largest single activation of this system ever organized by human beings. Messi has now scored in 7 consecutive World Cup matches, the first player in history to do that. 7 tournaments, 7 goals, every single time. And every single time, billions of people across every continent run mirror neuron simulations simultaneously. The same neurological event rippling through billions of brains at once. Not because people decided to care, because their hardware made them care before they had any say in the matter. This is not a trivial observation. Researchers studying the neuroscience of football fandom have found that the experience of watching a match activates not just mirror neurons, but a cascade of neurochemicals. Dopamine in the reward circuits when something goes right, oxytocin binding social connections between fans watching together, cortisol flooding the system when the result hangs in the balance. The brain during a tense World Cup match looks, in neurochemical terms, less like the brain of someone watching television and more like the brain of someone doing something that genuinely matters. Because to the brain, it does genuinely matter. The simulation is real. The investment is real. The loss and the victory register in the same deep structures that process real personal experience. Rizzolatti spent years after the discovery trying to explain what mirror neurons meant for our understanding of human beings. His conclusion was not complicated. We are not isolated individuals, he said. We are fundamentally connected to others through our nervous system. This is not a choice. It is what we are made of. The person in that living room who felt something explode in their chest when Messi scored was not being irrational. They were not getting too emotionally involved in something that doesn't matter. Their brain was doing exactly what it was built to do, mirroring the experience of another human being so completely that for a few seconds the boundary between observer and player, between them and him, became genuinely thin. You have never met Messi. You will never stand on that pitch. You will never feel what it is to curl a free kick past a goalkeeper in a World Cup match in front of 50,000 people. But in that moment, for just a second, a part of your brain did. And it had no idea it wasn't real.